assistance for that, Natalie.
Absolutely.
Okay.
Welcome everyone again. This is now being recorded for our YouTube channel. This Berlin User Group meetup is meeting online for the first time, and we have Ronen Botzer, our Director of Product, introducing Aerospike and telling us best practices on how to use this. The stage is all yours.
All right. Hi, everybody. So first being mea culpa, it takes a while for me to write these presentations. So these are actually recycled from a user group meetups in Tel Aviv. I would have stitched it a little better for the Berlin user group, but since the Tel Aviv one has had like multiple meetings already, and the Berlin one is just starting, I felt like it would be useful to review content that I did go over there. Now, it hasn't been recorded, and I think it's out there only in SlideShare. So if you've seen it before, my apologies, and definitely you can ask me some more in-depth questions, and I'll get to them. But otherwise, my apologies for recycling some of the content, but the content still applies. Okay, the other thing is struggling with Zoom is also a new thing to me for some reason. Things that I'm used to on the screen, like being able to use virtual desktops, is somewhat affected by it. Okay, so first thing, I've been at Aerospike almost 6 years, which ironically is the longest I've worked for a single company. I tended to work for startups before then. They would either get bought within 2 years by some other startup, or go out of business within 2 years. You know how that game works. So first thing, it's really nice to have stable employment. But beyond that, the main reason I'm at Aerospike is the product is fantastic. It's very easy for me to explain it and to use it. It's something that I would have used before in various previous iterations of my life as a data engineer or as an architect at startups that I've been. When I made a contact to the people at Aerospike through a mutual friend, we worked just a few miles apart, like a lot of people do here. But I was in the beginning like, why would I go work for a database company? I've only done consumer-facing stuff like applications in the past. Like I don't, I'm not this low level, and what qualifications do I have? But when I started talking to people about Aerospike, it hit me that this is something that I would have used in the past multiple times. It would have been mainly helpful in one thing that always stressed me out in my previous jobs, which was what do I need to do in order to scale, and what kind of iterations I'm going to have to go through as we get more traffic, more people, more data. The thing that is fairly unique to Aerospike that I've personally not run into anywhere else is that you can start writing your application with 10 gigabytes of model data, and you can deploy it to production, and it can scale without you changing the application to insane scales. Like we have customers that are in the petabyte range. And the thing about it is that Aerospike is an actual database, not a cache. It is as fast as a cache, so that already kind of removes a layer. In the past, I would have modeled always with, some system like a Cassandra or an RDBMS, and thrown an in-memory database in front of it, and built into the application all kinds of techniques to work with those auxiliary systems, right? Like you would do the usual, like go to the cache, and if it's not in the cache, go to the database and populate the cache, and worrying about things like how do you invalidate objects in the cache, use Russian doll techniques or whatever, all kinds of weird things to get around the fact that your database just cannot handle the number of concurrent connections, the latency that you needed from it. So Aerospike kind of like is an all-in-one system. It gives you the functionality that you expect from a database. It gives you the kind of like ACID semantics. It gives you, both sides of the CAP theorem, CP and AP, if you're, had to break your head over that problem with a distributed system. It's extremely fast, it scales well, and you talk to a logical cluster your application does not need to change as the cluster is being upgraded, through versions, through hardware, etc. So that was the reason I joined, and that, like, in a nutshell, is why I'm still here. Otherwise, I really like the people I work with. That's always a nice thing. And you know, I think there's a lot of cool things for a developer to do when using Aerospike. Now, using Aerospike, if you've ever had to use, something like Redis or Mongo or Cassandra, you know that there are specific modeling techniques in order to organize the data in a way that makes sense and to use it effectively, right? Aerospike similarly, has its own, modeling techniques that are useful for it, because it is in this kind of a weird zone where, on the one hand, you can access it in a key value way similar to Redis, but different from Redis is that all the different data types can live in a single row. So more like an RDBMS, they can be in a single row, and they can, you can access multiple data types through a transaction that does multiple, accesses multiple columns at the same time, in sequence, right? So these are things that you can do in Aerospike that you can't do in Redis. So it's a little, thinking about how to do these things is different. And this talk is an example of doing something that is, fairly easy to explain. A lot of the original users of Aerospike came from ad tech because of the kind of like scale and latency requirements that they had, that Aerospike was a very good fit for both of those. So I'm going to give an example of something from ad tech, but it is generally applicable to solving other problems with Aerospike. So I think, let me explain a bit more. So I explain why I'm at Aerospike. That's one thing. Quickly on my background is that I started as a developer on the PHP and Python clients. You'll still see a little bit of my comments in there here and there. My C code was pretty terrible. The person doing it right now is much more competent, so that's good for everybody. I moved to being a solution architect after that, to help people do what I'm trying to do right now, which is work with them on the application side and how to use Aerospike more efficiently, how to change your applications in ways that give better performance or scale better, or in general solve all kinds of problems. And that's been a lot of fun. And then recently, I've been in the like a product management role, where my personal agenda is to do as many developer functionality or developer features as possible, as fast as possible, because I want Aerospike to be something that is just very useful for the application side, not just for the operation side. Aerospike, if you don't know, is a distributed database. It's been around for 10 years now. It's been designed from the ground up as a distributed database. So everything in the modern era, in the information age, is a distributed database. There is no such thing as a single node database anymore, especially if you're exposing it to the internet, right? So there are databases that were designed as distributed database with those concepts built in, like Cassandra and Aerospike. We're both influenced by the Dynamo paper, for example, and which is not DynamoDB, but just the Dynamo paper from Amazon. And if you think about Aerospike from an operational side, you'll see that it thinks about clustering in ways that are not unlike Cassandra. Other systems, though, have had to become ad hoc, built for clustering. Things like Redis, MySQL, etc., Postgres, whatever, you still need to be able to cluster them because they're just not going to be able to handle the load as a single node. Like this old school RDBMS approach doesn't exist anymore. So, there are all kinds of techniques to ad hoc cluster things, which is, using sharding on the application side, where the application decides to only talk to a specific database, and splitting the data based on some kind of hashing. There is, kind of like proxies that are bolted on top of a non-distributed database, like, what Redis Labs basically is doing with Redis, which is, most of their work is on the proxy side, not on the database side. Redis was designed to actually run on, be a single threaded system, originally single core. and being able to do multiple of those requires a proxy. So there are all kinds of techniques to doing that, but Aerospike was always designed as a distributed database and has therefore a lot of strengths in that space. It can cluster very well, it can grow really well. You can deploy Aerospike across, 2 zones in the same region. In theory, you can deploy Aerospike across even farther distances. But the nodes always know about the state of each other, and they know about the distribution of the data. Everybody in the Aerospike ecosystem, the clients and the server nodes, are always aware of the partition map. They're aware of the distribution of data, so you can access the correct node with a single hop always. So that's really one aspect, is clustering. The other aspect that is kind of unique to Aerospike is the way that it was designed to take advantage of solid state technology. So every database out there is designed with a specific reference hardware architecture in mind, right? RDBMSs started in an era where you had 16-bit CPUs. They were single CPUs, right? It wasn't multi-core anything. RAM was very expensive, but disk was, by far more expensive. Disk was really limited in the amount of space it could hold, and there was a huge speed gap between RAM and disk. So, you wanted to cache as much as possible in memory. You wanted to put indexes in memory. You did not want to go to disk if you didn't have to. That is the reference architecture of RDBMSs. In-memory databases like Memcache, caching systems like Memcache and Redis were designed, over this wave of improvements in memory technology in the sort of late 90s and early 2000s, where memory kept getting faster and cheaper and denser. You can put more on a single DIMM slot. The memory cost per gigabyte went down, and there was at the same time this need for better latencies because of all these internet applications, and our DBMS is not being able to cut it without any kind of like cache in front of it. So those systems are designed with the fact that there's plentiful DRAM per node, and that's what also a lot of first generation NoSQL systems have. First generation NoSQL systems like Cassandra still need to cache an enormous amount in memory or Couchbase, right? They're always about your hot data and how much of that, making sure that a very large portion of that, 80 to 95% of that can fit in memory, and you need that much memory for your SS tables, for whatever. Aerospike, however, was started around 2009. I think the first customer is 2010, so that's why we say we've been around for 10 years now. Was designed with SSDs in mind. So solid state technology now covers both SSDs, whether it's, most of them by now are NVMe, and persistent memory now, like Intel Optane persistent memory. That really is what Aerospike is designed to use. The idea is that we don't want to cache things in memory. We want to go directly to disk. And it uses very little memory compared to in-memory systems. And we're riding this wave of SSDs or any kind of like solid state devices, whether it's a memory or disk, becoming faster, cheaper, and denser all the time. Like when I started, we have our ACT test, which is like an open source tool to benchmark drives by hitting them with actually database loads, which are a mix of different size objects of reads and writes happening all concurrently. And that test is out there, and it's used by Intel and Samsung and others to benchmark their drives, and we can use that for capacity planning and to kind of like apples to apples compare between drives. Now, when I started, so in 2014, June 2014, the fastest drive out there had like a 70x rating, where this X rating means you can do 2,000 reads and 1,000 write for each X. So 70x is 140,000 reads, 70,000 writes concurrent, and they and that'll give you 95% of operations sub-milliseconds for 24 hours. Because for 24 hours, it doesn't exceed that. 70x was the fastest that existed. Now, almost all drive manufacturers, Intel, Samsung, Micron, etc., give you, 100x or more. and the cost per terabyte is like a quarter of what it was before. So that is kind of like what Aerospike is designed for. It's trying to be a distributed database that is running on top of SSD or solid state technology. All right, enough with the intro. I'm gonna move on to basically modeling. So this is an example of how to do user segmentations using Aerospike's maps and Bitfield operations. Okay, so first thing I'd like to mention, the Aerospike developer blog that exists on Medium. There's also a developer blog presence on Dev2, if you prefer that. For example, I have an article that, or a few articles there that also touch on what we have here now, this user segmentation. So that article is already posted there if you want to look at it later from a blog perspective. And it's linked to code on GitHub that I put up for that article. Okay, let me take a quick look at the chat. Okay, fine, all clear. So the short of it is that Cassandra databases have this issue when it comes to modeling of a needle in a haystack. When you are trying to model the same thing that we're going to talk about here, you require a very large number of very small rows. And in order to find all the associated data, you need to do a scan or a query that actually takes a very long time relative to Aerospike to retrieve. In Aerospike, we model pairs of data in a single row using something like a map or list data type. And that's something that we're going to go over this. And single key value operations in Aerospike are extremely fast, typically hovering around a millisecond, depending on how much load you have or the hardware you have. It can get to microseconds, or it could be a little bit over, like 2 to 4. But on a whole, these are extremely fast operations. And the idea when you're modeling these type of things is to be able to retrieve it all in a single read of a record. So quickly, what is a user profile store? In places like verticals like digital advertising, a user profile is something that holds, for example, all the audience segments of a user. So typically in ad tech, over time, as you're using things, information about you is, if you didn't know, I'm sorry, cover your eyes and close your ears, but a lot of information is being gathered about you, whether you're opting in or not, GDPR aside. And it's, and then things are deduced about you, behavioral, demographic, geographical information. And these all are tagged as, these enums, which are basically segments. So, I live in California in the Bay Area. That would be one segment. I like basketball is another segment. I happen to watch Golden State Warriors might be another segment, right? How specific they are, or how wide they are. I'm male is obviously a really weird segment because about 50% of the world falls into one or the other. So some segments are gigantic and will have billions of cookies or users associated with them. And some of them are pretty sparse. Like, if you like playing electric mandolin, maybe you're in a really, really tiny segment. The goal for ad tech is to be able to pull out information about you extremely fast, because typically in the real-time bidding world, if they need to determine, a demand-side platform is going to get a URI of where they might be able to place an ad and a cookie saying, like, I see this device, or I see this cookie that represents, some anonymous user. And they need to quickly pull out information about the user, like retrieve this user from the user profile store, look at the segments of the user, compare them to campaigns that are active, decide whether it's worth going into a bidding war on an exchange for this user, and then they need to also serve a specific ad to the user. And all of that within about 100 to 150 milliseconds. That leaves extremely small margins for all the database operations. Those typically need to wrap up in like less than 10 milliseconds if possible, because you need all this extra time for network hops to the exchange and serving the ad itself. So time is of the essence, and this is the space that Aerospike grew in. So this whole concept of being able to do things very fast at really high scales is something that kind of like was, it evolved into. And that's why it applies also into other kind of real-time use cases. So modeling this, though, is generic for any type of online personalization. Like we've used, I've talked about the same technique with a very large e-commerce company, because again, when you go to an e-commerce page, they might want to get the information about you, things that you've looked at, compared to you to a cohort that is similar, and see, people that like, I don't know, science fiction probably will also like these products, right? If I'm searching for, The Expanse, they might want to offer me an Expanse T-shirt that is hot right now with other bald nerds that like sci-fi. Okay, so that's an example of what audience segmentation is. So in Cassandra, you would typically, let's say you have a user ID and a segment ID. This pair will go into a really simple table, and you can have associated attributes. But the two things that are the primary key that you kind of partition on is this pair of user ID, segment ID. So let's say you have, so now there's a scale problem here, because let's say you have on average 1,000 segments for each profile. And we have a customer, and if you read my article on Medium, you'll actually, I can refer to him by name now, which is the Trade Desk, and they're a gigantic, I don't know how they define themselves, but they live in the ad technology space. I think they have a better definition if you look at the YouTube video that's attached, and they had, when we were looking at this, 50 billion cookies. If you multiply that by that 1,000 segments, that means a 50 trillion row Cassandra database. Now, in order to find a specific user, you need to find these 1,000 segments, these 1,000 rows out of a pool of 50 trillion. So even with partitioning and kind of like knowing which area or which node to scan, that is still a huge scan that takes a very long time to retrieve, like many, many seconds. And that actually forced them to do things in a very different way. So because they couldn't retrieve a single user, they had a system where they have an edge database, and the edge database, they will first look in that edge database for the cookie. If they can't find the cookie in that edge database, they will go to this larger cold store to retrieve the user. Now, because they just couldn't, the amount of time, many seconds to low, to minutes almost, to retrieve it is not practical. You're not able to participate in bids. This user is currently active. You see their cookie, that means they're online, and that's when you want to bid for them. It just is, it's going to take too long to do it. So what they had to do is they had to actually go in a different angle, like perpendicular, and go when a new campaign was being targeted, and that campaign targets, let's say 50 segments, they would have to go and warm up all the users that have those 50 segments from Cassandra into their front end database, which happened to be Aerospike. And that would take, just like, the system was just running constantly, because on the one hand, it is doing updates constantly about the data about users, and data is expiring, and also they need to be able to do these huge scans in order to warm up the cache, and it just wasn't practical. So we looked at doing this differently in Aerospike, and in Aerospike is a row-oriented, not a column-oriented database, if that means something to you. And in Aerospike, you basically would have a map with all this information and have all of it sit together in a single record. So the key would be the user ID in order to get the row. And within that row, there would be a map, and the map every entry in the map would look like this. The map key would be the segment ID, and the map value would be a list, where the first element of the list is the segment TTL, because one of the things they want is they want things to expire, because the idea is there are some segments that are temporary. Like geographical changes more than, say, my taste in music. Okay, like right now I'm in California. If I go, if I go to Berlin for this meetup and I'm going to be there for a few days, then my current location has changed. My the geographical data about me has changed. Like maybe now they want to serve me ads for, I don't know, places to go out in Berlin. That is only going to be temporary. So they want the other geographical bit to expire. So there are things so this data keeps coming in and keeps getting updated all the time. And segments have TTLs. The ones that are weak or that there are very volatile, like I'm currently looking for toilet paper, is a very volatile thing. Once I get my giant stash and I have a shotgun to guard it with, because of the roving hordes of toilet thieves. I'm actually looking at my toilet right now. Toilet paper. It's a good stash. The second I fulfill that, it's done. There's that interest is going to go away. So you want those things to expire, and you want new updates to be able to refresh this. So first thing, we'll get in a second to why we're doing this. So this is the format, and then all the other bits of information are kind of like down the list as, in this case, as a map of attributes that are specific to that segment. So maybe you have a segment that says you're interested in a vacation in Hawaii, and associated attributes could be like the time, like the dates that they're deducing based on my ticket purchase, or maybe even which island I'm going to be on. That is going to be specific to a vacation in Hawaii segment, if there is such a thing. I don't know. I just invented that. Maps in Aerospike can be unordered, k-ordered, or kv-ordered. And I chose k-ordered in this case for the, it happens to be the best performance on SSD. But you can also do kv-ordered and pay a little bit more in terms of the operations are all the same in the map API. It's just that their performance is different depending on which of these options you choose. So let's talk about upserts, right? Because we said that there's constantly this need to get information from DMPs, data management platforms, which are the people that kind of like buy and sell data about you, or collect information about you, however you want to say that nicely. You want to get information coming in from partners, et cetera, and you want to process the segments about the user. And that needs to happen constantly. So we want to be able to update this map in a way that is still very efficient for a lot of reads also happening. So this example lives in GitHub under Aerospike examples. Modeling user segmentation is the repo that I created, and it's associated with that blog post as well. So I'm going to use Python, both because it's concise and because I like writing it better than Java. You guys can convert it to whatever language of your choice. So let's look at this. We have, we're creating an example segment. And first thing, this ops thing, this is a multi-operation transaction. Aerospike does not do transactions on multiple keys, but it can do multi-operation transactions on a single row or a single record in Aerospike terms. So what I'm doing here is that I'm getting a specific segment by key. So the map get by key operation is obviously, I have a k-ordered map, and it's going to be very efficient if I do that. I'm also going to put a single segment in there, and then I'm going to get, so in this case, I'm just changing the segment TTL really, and then I'm going to get it. Now, if you look at this article, what I do is that I randomly create a user profile, and then I do this update. Now, the update, it's going to be an upsert. If it doesn't exist, it will actually enter it there. And if it does exist, it's going to just update in place the segment in the map. So when I'm creating this randomly, I don't know if it's there or not, but you'll either see that it's new and it'll have the segment TTL, or you'll see that there was a segment already there with an older TTL, and now we've updated the TTL. So in this case, we've just kind of like pushed the expiration forward in time a bit. So advantages of this is that we can also do this thing, which is like we can get things by value. So if you remember, if I go back a couple, the map key is the segment ID, and the map value is a list where the first element of the list is the segment TTL. Now, if I do get by value operations, they order, the way Aerospike compares things is that they order the lists and these lists by their by descending order by what's in them. So the first thing it's going to do is it's going to look at this leftmost value and see that it's an integer, and it's going to sort it. So if I'm trying to find things in a value interval, it will tell me all the segments that exist that are between two extremes, between two lists that also have a TTL as their first element. So if I want to, for example, find all the TTLs that are in a specific time range, because I want to find the freshest things, like the newest things that have been updated, the ones that are like the nearest to expiration or the farthest away from expiration, meaning they've been updated most recently. Because let's assume that we always push a constant amount of time into the future. Then what I'm doing here is that I'm saying find me the interval between basically the in this case the beginning of time and a specific NTTL. Okay, these are two lists. You can see that the leftmost and the rightmost for this get by value range is a 0, and in this case we're using an application epoch. We're not going to use a Unix timestamp because we really don't care about having these like very large numbers that started at the first second of 1970. If this application was deployed in January 1st, 2019, that could be the first second, or in this case, we are modeling that we care about expiring hourly. So it's, the number of hours since January 1st, 2019, for example. 0 would be the beginning of 2019, and NTTL would be wherever point in time that I want to give it. And then it'll retrieve all of them. So even though I have 1,000, on average, segments in that map, this get by value interval can go and fetch everything that is in there with one call. And it's very efficient because, again, it takes a lock on the row, it does this operation, and then it releases the lock, and it's done really quickly. Now I'll point you to some one weird thing that is happening here, which is the difference between the name, the generic name, which is get by value interval, and the name in the Python client, which is map get by value range. So Aerospike doesn't have a query language. Okay, it's not like SQL, which is a generic, high definition language that's kind of like human readable, right? Aerospike is actually all about efficiency. So there are specific language clients. There are SDKs for different languages, right? There's a C client, there's a Java client, a Python client, etc. And they all implement the same wire protocol. And the wire protocol basically encapsulates the call and the data, and that goes to the server. The server, does the operation, and then it answers with a wire protocol, which is, encapsulating the resulting data from that operation. When you look at the map or the list API, if you go to the Aerospike, docs.aerospike.com, and you look under data types, and you look at map and list, there'll be their API. Those are method names that are generic, right? They're not necessarily the names of the method on the server or the clients, but we just use those to be able to refer to the same thing. Now, the Java client and the Python client just implement the same thing. In this case, the Python client is a little quirky. Probably my fault, might have been my one of my the people that followed me, where the name is not exactly the same. Sometimes it's because of trying to be idiomatic. Sometimes it's an idiot developer. If it's me, I'll take that on me. But on the whole, I'm going to be referring to the generic method names. So another advantage is that we can also quickly, with a single operation, expire all the segments that we want to get rid of. So this data is going to continuously grow, right? If nobody is actually trimming this data, then this database, even if we weren't adding cookies, if we weren't adding devices or users, then it would still continue to grow because more and more segments would come in. But some of these segments, like we said, are stale. So you can use this map remove by value interval operation to trim the segments. And that would be with a single call. So all of this comes down to that we now can, because of this change in modeling, we are enabling this customer to be able to retrieve all of the users of a specific, all the segments of a specific user with a single read operation, which is going to come, instead of in many seconds like it did from Cassandra, in basically, you know, less than a millisecond or up to 4 milliseconds, you know, depending on how much load is on the system and on these drives. Okay, so because again, this, instead of having many rows, we went down to a single row because this is a row-oriented approach, and we can do that. And in this case, this kind of personalization, we are talking about a single user that is going to a site or interacting on specific URI, and we can retrieve it all because it's just one record. The other advantage is that this trim operation that we're talking about, we don't have to do it on every time we do a read. That was actually a mistake that the application developers were doing. This remove by value is fairly heavy. You have to find all the segments in the interval, right? So we have to kind of like compare between these two begin and start times for every single one of the 1,000. And that could be pretty heavy. I mean, that's a lot of CPU to do, and you only need to do it really, you know, once an hour, once a day. Aerospike, since 4.7, has the ability to do an operate, which is our kind of like most of the client's name for a transaction, do an operate with this remove by value interval, and apply it with a scan to every single record that it meets. So it can scan over all the data on every single node of the cluster in the background, and do it fairly slowly, and do it once an hour or once a day. Just call this remove operation once, and then you know that you kind of like don't need to care about it when you're at the read level. You don't have to combine a read operation with this remove every single time. And again, this gave literally 3 orders of magnitude faster retrievals of data from this type of data store. The size of this thing, again, it's mentioned in the YouTube from the trade desk, it's a petabyte of data. So the cool thing about this is that Aerospike, to retrieve a single record, to do operation as a single record, it does not matter how much data is around it, because again, we're not scanning. To find a single record from Aerospike perspective, you issue from your application the command to the Aerospike object of the SDK. Okay, so the Aerospike client. The Aerospike client is aware of the partition map, so it knows exactly which partition this record lives on. That's a constant kind of hash operation. And it knows by a lookup into the partition map exactly which node has the master, is holding the master of this partition. It goes to that partition. In that partition, we have the primary index as this kind of like hash table of arbitries. So this hash table will drop you to the correct sprig. The sprig is an arbitry. It's just now a kind of like n log n kind of operation to find within the very small amount of data that is actually indexed by that specific arbitry. So you have a bunch of these O1 hops to get to this O of n log n, and n is fairly small. It's not the whole 50 billion rows that are in this database. and then you go straight, this metadata that you find in the primary index tells you with one hop how to get to the record on the disk. So these are all series of like very, very efficient operations. And you go, so the fact that there are 50 billion records around it doesn't change the access time at all. So it's kind of like the opposite of when you are in the Cassandra land. Okay, and before I move to the bitwise version of this, does anybody have a question? All right, I'll wait a few seconds. Check out that my toilet paper hasn't been stolen. It's very important these days. All right, so we talked about how to model this with the map API, and I encourage you guys, if you haven't looked at the documentation, take a look at the map API. It is fairly extensive. You can do a lot of things with maps and with lists. We added the bitwise operations, basically bitwise operations on a blob. The blob data type has been around for a long time, but it didn't really have any API associated with it. It was used in the past by people that would do things like, back when Aerospike was used kind of like a blob store, a big distributed blob store, people would kind of like do everything on the application side, turn it into protobuf, gzip it, send it to Aerospike, and it would be just a blob sitting there, and then somebody would pick it up. So it was a lot of get put operations, not a lot of these atomic list and map operations. The modern era gives you all these atomic server-side operations, which really are more efficient and actually better to use in a lot of cases. So, you probably want to move away from the blob store approach if you can. But if you just, if you want to model with a Bitfield, there's a lot of things you can do with a Bitfield if you have bitwise operations for them, and we added that in version 4.6. So if you're on the community edition or enterprise edition, that is there for you. So let's go quickly over what is out there. First thing, there are these general write flags that apply to all the different write operations. You can say that you want to create only, like you only want to have something that creates a new bitfield, or update only, like the bitfield needs to already be initialized, but you also can just leave it as is, which is kind of like an upsert operation. You can tell it that you want it to not fail, because if you're chaining several operations in a row, you might be actually want it to just skip to the next operation if the first, if the previous one failed. And that also exists for list and map, by the way. So you may want to say, oh, I want to initialize something if it doesn't exist, or I want to update it. So like, let's say map operations have the ability to increment an integer value inside a map. So you may want to say, hey, if it doesn't exist, then create it and initialize it to some number, like 100. But if it does exist, I want to increment it by 3, whatever. So you can have an operation that says, okay, create only at this key the value, 100, and with no fail, i.e., don't throw an exception if this doesn't work. And then the next one is just increment by 3. So this way you can, start it out at 103, by starting from 100. Or if it does, if the create only failed, you say no fail, it'll just skip to the next operation and just add 3 to it. Bitwise has the same kind of thing. Partial means apply certain things. You're okay to apply things in a partial way. So for example, if you are trying to resize, you may want to actually, or let's say, I'm trying to think of something really on the fly. You may want to add or do something that, like, in theory would extend the size of the bit field, and you only want to work on the bits that are within the current bit field and not make it any bigger. So you can tell it to just do it partially, to whatever can fit should fit. So the things that we have is the ability to resize the bit field, and that is obviously can be destructive. So you can tell it how you want it to behave. If you're scaling it down, you can make it larger too. You can insert things into the bit field which will move them over. or you can set certain bits. You can remove also certain bytes out of the bit field. You can apply OR, AND, XOR, and NOT logic. You can left shift and right shift this thing. So move all the bits left a certain amount or right. You can do integer math on a sequence of bytes. If you have, if this is bit field and, kind of like that means that position has meaning. So certain bytes might be a register or something, and you can do, add, subtract, or set the integer in a specific sequence of bytes. You can get all the bits that are raised. You can count them. Again, you can left scan or right scan for the first bit that is raised that you run into. And you can tell it, oh, I want to left scan for the first 1 or for the first 0. And you can get the integer at a specific location of bytes. So how would we basically model user segments with a bit field? So let's say let's say that these are, continuously enumerated, right? Like there's 2 million possible, different segments, and they just start at 0 and go all the way to, almost 2 million, right? So we're making that assumption. And let's say that each integer in this enum is going to map to a specific bit position. So, if you have segment 1000, we are going to raise bit 1000 to say that you have this segment, right? So in this case, the bitwise operations are going to be applied multiple side, and you can use them to see if a user is in multiple segments all at once, right? You can use these mask operations basically to find something. The other thing is that if you are using Enterprise Edition as opposed to Community Edition, you have the option of using storage compression, which is kind of like transparent to the operations side. So if you are using compression, basically the operations still happen. Aerospike reads the record to memory. It does the operations on the memory version of the record, and then it saves it back to disk. Between the point where it says, "Hey, save this to disk," there is a kind of compression storage algorithm that'll pick it up and compress it just in time. And a bit field like this will compress extremely well. So let's say it's in theory 2 million bits wide, which is quite a bit, but you only have 1,000 on average. You have huge sequences of zeros that are repeating. If you're using, if you choose to use a codec like a Z standard will introspect into that and compress that extremely well, even if you're using, like, say, level 1. And that is, by the way, something that the trade desk is using for their very large database. So even though it's logically like around a petabyte, it only, if they're getting something like 0.25 compression ratio, which means it's only 250 terabytes of storage that is needed actually on disk. The caveat is that I have yet to think of a way to have this TTL approach, kind of like that the maps have, where you can say a remove by value interval and get rid of all the segments that are too old. You might just need to reprocess and just kind of like zero out and replace every time, like and just kind of like reprocess and always have the latest stuff in there. So I'm giving this as an example. It's not a perfect example. This is really just so you guys can think of modeling things with, in this case, with bitwise operations. So just a quick round of links. All this exists in Aerospike's docs, and I have links here. We will post later, to the Python client, to the actual kind of generic operation documentation for it, explanation of how we do these comparisons to find, order in a value, because again, we're using, if you remember, we're not really using the TTL as an integer, we're using it as an integer that is the first position of a list. So how does that actually work, as explained there? If you look at CDT ordering, there is the code sample on GitHub, and I don't have the link here, but if you go to Medium and you look for Aerospike developer blog, you'll be able to find it. So this is typically where I would stop. we still have a little bit of time. I'd like a show of hands for who wants to hear a little bit more about modeling with bitwise operations. I have some more examples from another talk that we can go through fairly quickly. But, and if you have any questions about this, about modeling or the specific use case.
We can do the show of hands via the chat, right? Yes, no.
Please. Let me see if I can get to the chat.
Don't worry, I can tell you.
Okay. All right. Okay. I guess we didn't say
Just
what do
you.
you need to do, whether raising your hand means you want to keep going or if you want to talk. So in the meanwhile, if you have a question, just type it into the chat. If you are interested in another round, a much shorter one, probably 20 minutes, to talk about bitwise operations further, then raise your hand. And if you want me to can it, I'll be happy because it's right around lunchtime and I can go eat. So it's up to you.
So if you're interested in continuing, please type in the chat yes. If you're not interested, type in the chat no.
that
And the chat is quiet.
Explicit would help in this case.
First request to continue.
All right. Hey, first request, if that's the only request that we're going with that, that's the threat to everybody. All right. We got a no.
Yes, we have a one no.
All right.
I am suggesting we can have, as an intermediate break, we can have a few words from Srini, who is the co-founder here, to just say a few words about Aerospike, and then we can pick up from there for the second part with those who are interested to stay. Srini, if you can hear me, please unmute.
Yes, I can hear you. Thank you, Natalie. I don't want to take too much time, but just to, I would like to thank all of the people who are attending this. And as you might have seen, Aerospike is focusing on adding more support for developers and operators. We just announced an Aerospike Cloud product line, and we will continue to make progress on this. So please give us feedback, is what I will request. You can send feedback through the meetup, to Natalie, to Ronen, as to what we might do to help make it easier to use Aerospike from a developer and an operator point of view. And once again, thanks for attending this.
Thank you very much. So we received some yes and some no. And my suggestion is that we'll have a session of questions and answers about this talk. And then those who are interested to continue with us will continue for the second part. So any questions, Ronen? You can type your questions, or you can unmute the question, unmute yourself and ask the question. We will wait a few moments. We saw that it can be tricky to find the unmute button. So I'll use the time to say that all the different links and the places to go to that Ronen mentioned during his talk, for example, the documentation, for example, the blog post, for example, our GitHub, this will all be links that will add to the meetup page, and also it will be in the description of the YouTube video. All right, then few more seconds for the time. Yes, no? All right, no more questions, looks like it, or no questions. So looking at the agenda, we're actually 15 minutes short of finishing. So this might be too little time to start a second talk.
Yeah.
But we will host a second future events where we will have this talk about the bitwise operation. So I will use the chance to say thank you very much, Ronen, for the time and for giving this talk. And thank you for all the attendees for showing up and for answering the questions. It's really nice to see 100% response rate. You all rock. And our next event is already announced. It will take place online as well. This will be in April 15th. And you can find the link to that on our meetup group. And we will have a talk about, we'll have a talk from our VP of Engineering, who will talk about strong consistency in databases. So thanks again, everyone, for showing up. If you want to chat more with us, we are on Reddit. Just go to Aerospike on Reddit, ask questions, we will be answering there. We will stick around in this chat for another 10 minutes or so if you feel like asking a question off the record. But step one will be actually stopping the recording.